All right, day one notes. Here we go. Everything that they want you to do on this first page pretty much is they want you to either plot points here, graph these, and then just take a look at what you observe. But we're pretty much doing that on side two of our notes as well. So let's just go ahead and move to side three. Let me zoom in. All right. Example one. They have given us a set of ordered pairs and they want us to identify, is this a function or not? Just look at all the x values. And as long as the x values do not repeat, then it is a function. So yes, this is a function. List the coordinates of the inverse. To find inverse of a set of ordered pairs, just switch the numbers. So the inverse of 0, -3 is -3, 0. The inverse of 1, -4 is -4, 1. The inverse of 5, 2 is 2, 5. And the inverse here is -4, 6. Easy. And then they want us to identify, is the inverse of the relation above a function or not? Well, let's check those x values. This is not a function. No, the inverse is not a function because these x values repeat. Now, looking at a pair of graphs, they want us to identify, are the two relations inverses y or y not? This one here, example A, no. Now, quite possibly, the most easy way to identify, are they inverse relations or not, is just look at one of the graphs and identify an ordered pair. Okay, so right here, this graph has an ordered pair at 0, 0. Now, what's the inverse of 0, 0? 0, 0. Does this graph have a point at 0, 0? No. No. So they're not inverse operations of one another. If we were to perform that same test here, I'm going to use this point here as a point of reference. Gosh, that's small. What is that? Right here, is that 0, -3? Yeah. That's what it looks like to me. All right, so 0, -3. What's the inverse of that? -3, 0. So let me see if this graph has a point at -3, 0, and it does. Now listen, you'd want to test more than one point because sometimes they might have a common point or inverse, but not always. But this one here, yes. But if you're going to use this method, use more than one point to test. This one here, no. This one here, yes. All right, moving on down. Graph 0, 3 and its inverse. I'll let you try that. I'm gonna give you about 10 seconds. Graph 0, 3 and its inverse. All right, hopefully that's enough time. Let me start by graphing 0, 3. 1, 2, 3. And the inverse of 0, 3 is 3, 0. So let me. Okay, now here's the reason why they have this line here. And by the way, the equation of that line is y equals x. I showed you one way that you can identify whether or not functions are inverse operations or not. Take an ordered pair, flip them, and then see if it matches with the other graph. Another way is this line right here represents the equation y equals x. If I were to take this piece of paper and fold it over that line, these two dots would be right on top of each other. So that's another way you can identify whether or not they are inverse operations of one another or not. This one here. You know what? Before we do this one, let's move over to this side here. I think this is better to begin here. This one here? Yeah, they're inverse operations. Okay. Example 7. Find the inverse. By the way, this little symbol right here, that represents inverse. So find the inverse of the functions below and check by graphing in a calculator. We're not going to do that. None of this requires a graphing calculator. All right, here's how you find inverse operations. The equation of this line is y equals 2x minus 3. Agree? That's the equation of that line, y equals 2x minus 3. To find inverse, switch x and y.
I had this reminder.
And then start solving for y. So I'm now going to add over 3. Then I'm going to divide everything by 2. And we have 1/2 x plus 3 over 2 equals the inverse. And I gave the y an exponent of -1 because remember, that represents inverse. That's how you find inverse operations, everybody. Switch x and y. Start solving for y. So for example B, we had to find the inverse of that one. Example B, it's y equals 1/2 x plus 2. Let's switch x and y. Then start solving for y. Subtract over 2. Now we have over here on this portion of the equal sign, we have 1/2 times y. The way that I think is the best way to get rid of that is let's multiply both sides of this equation by the reciprocal. The reciprocal of 1/2 is 2 over 1, or really just 2. So let me multiply this side by 2 also. Looks like we have some distribution that I need to do here. 2 times x is 2x. 2 times -2 is -4. And now we have found the inverse. Do we think we know how to, at least, we have an idea of how we would solve for inverse? Okay. Then let's go here. Let's take a look at example 5. Given f of x equals x squared plus 1. Are we all on the same one? Very good. Given f of x equals x squared plus 1, graph its inverse. Let's find out what the inverse is first. So we know that this is y equals x squared plus 1. Let me just switch my x and y's. You don't need the parentheses. To be honest, I don't even really know why I wrote them. I don't know. But you can have them. It doesn't matter. All right, now let's start solving for y. Subtract over 1 first. To eliminate a square, square root both sides. And if you are solving a problem where you have a square in the problem and you have to square root that, remember, you have to put plus or minus in front of the result. So we've now found the inverse. It's plus or minus square root of x minus 1. So let me write that down here. Plus or minus square root of x minus 1. Okay, if we were going to graph x squared plus 1, I think it's been a while since we graphed quadratics. But if we were to graph this quadratic here from the origin, I'd move up 1 and I'd put a dot. That's where my vertex is. since there is no number in front of x squared, we can use that pattern that I showed you guys a while back. We can go right one, up one. Then we can go right two, up four. From the vertex, go right one, up one. Go back to the vertex, go right two, up four. Now back to the vertex, I'm going to do the same thing, but this time on the opposite side. Left one, up one. Left two, up four. And then I would connect. All right, now this one here, I'm going to be honest, I can't remember. I don't even know if we've graphed square root functions yet. This one, now we have to graph that. And if you don't know how to graph square root functions, any ideas what we could do with this graph to figure out how to graph the other one? That's exactly what we do. I know exactly what that sign means. Yeah, we know what these ordered pairs are, don't we? So what you could do is you could write them down. -2, 5. -1, 2. We have another ordered pair at 0, 1. I wrote down all the ordered pairs that we just plotted earlier. Now to graph the inverse, flip them and graph those points. So let's do that. Let's start flipping them, and then we'll plot those points. Yes. Ask me that one more time.
If there's two fives and.
Oh, yeah, I got you. I got you. No. You would not need to graph them to determine that. But it tells us to graph these, so we're going to go ahead and do it anyway. All right, after taking my ordered pairs, flipping them, plotting them, and graphing, that's what I have. Is the inverse a function? And as we were just pointed out, we could have identified that before we even graphed, because we have two repeating x values. So no, the inverse is not a function. Now, if they just gave you the graph, however, you could tell if it's a function or not by performing the vertical line test. And if you're performing the vertical line test and it crosses your graph more than once, you know it's not a function. Okay, the domain. The domain of this function here is all real numbers, negative infinity, positive infinity. The range of this function from bottom to top, range from bottom to top, that's going to be 1 to infinity. And now you see this symbol here, f to the -1. Now they want us to do inverse. Inverse. What do you think is going to happen here? They're going to change. Right. So the domain of the inverse is 1, infinity. And the range of the inverse is negative infinity, positive infinity. These just trade places, but the infinities, they don't change places. That's a good question. Whenever you're doing domain and range, it always has to go from least to greatest. Always least to greatest. We have quite a bit to get to today, so I'm gonna skip this one here. I do have some people that are still needing to take a test and get caught up, so I want to get them started. Let's go ahead and move over to our last slide of notes. And just a friendly reminder, anything that I've skipped, if you're like, oh my gosh, I really wish you wouldn't have skipped that, come talk to me after our notes. We'll go over it together. All right. Next, which of the following functions is slash are a one-to-one function, and why? Well, let me tell you, if they give you a graph and you do the vertical line test, you can tell if it's a function or not. So this is a function because it would pass the vertical line test. To determine if it's a one-to-one function, see if it'll pass the horizontal line test. Would it pass the horizontal line test? No. So this is not a one-to-one function. What is a one-to-one function? A one-to-one function is a function that is a function, and its inverse is also a function. Yes. Well, from the vertical line test, how do we determine if it's a function at all? Like, how do we know performing the vertical line test if it's a function or not? How do we know that? If it crosses the graph twice, right? Same rule applies to the horizontal line test. If it crosses the graph more than once, then you know its inverse is not a function. So it's pretty much the same principle as the vertical line test. This one here, these, if you were to perform the vertical line test, it would pass. If you were to perform the horizontal line test, it would also pass. So yes, this is a one-to-one function. I'll give you about 5 seconds for this one. I'll let you write down yes or no. All right. Well, it is a function because it passes the vertical line test, but it would not pass the horizontal. So it is not a one-to-one function. So no, not a one-to-one function. Okay, here's what I need you to do now. If you've already taken the test,